Now this is a AC signal generator. This is a output knob. This I will connect it to the CRO first channel. These are the two negatives that I will connect it together. Negative of the CRO and negative of the signal generator. Then positive of the CRO and positive of the signal generator. I'm connecting. I put on the power. So an AC signal is coming from this AC signal generator. Now we will observe it in the CRO. Now I have connected an AC signal from the AC signal generator to the first channel of the CRO. So you can see the AC signal. I have released it from the ground position and pressed this button for AC. So this is the AC signal. Now you can see how many divisions is the amplitude. If this is my ground, so this is my reference. If I release it from ground, this is one division. Peak to peak it is two divisions. From the reference 0 it is one division. So one division into the multiplier over here, it is 1 volt per division. It's 1 volt per division. The multiplier is in 1 volt per division. So 1 division into 1 volt per division, it is 1 volt, or if you take peak to peak, it is 2 volt per division. 2 divisions into 1 volt per division, that will give you 2 volt peak to peak. Or you can say it is 1 volt AC. From the reference, it is 1 volt up and 1 volt down. 2 volt peak to peak. So this is how you will measure the voltage or amplitude of an AC signal. Now let us think about measuring the time period of the signal. I can use this hold button, adjust it to make it remain stationary. I can use that. With the help of the hold button, I can make it stationary usually. So it is almost stationary now. Now we have to measure the time period in order to calculate the frequency. So how are we to do it? First you should measure the wavelength, or the time period of a single wave. So it's better to keep it stationary. I'm using the level knob as well as the hold button to put it stationary. Now it is almost stationary. So from here to a similar point, this is one wave. I'll repeat it. From here, this goes till here. Okay. Or from this peak to next peak, you can always take, because it will refer to one signal. If I want, I can put this down also. I'll shift it down and hold it. Now one division from here to here. So one wave is one division. Just see it, here to here, it is 1 whole centimeter on one division. So one division into, let me see the multiplier, time multiplier here. It is 0.1 millisecond. It's 0.1 millisecond. So one division into 0.1 millisecond. So it is 0.1 millisecond. Am I right? One division into 0.1 millisecond is 0.1 millisecond. That is my time period, so that I can calculate the frequency as 1 by T, or it is 1 divided by 0.1 millisecond, that is equal to 10 kilohertz. So the frequency of this signal is 10 kilohertz. Hope you have understood how to measure the frequency of this AC signal. Now, the next session would be to explain the various knobs on the CRO. Now that you have got an idea what is a DC signal, what is an AC signal, how they will look like, how is the CRO screen, you can take any point as a origin and measure your y-axis as your voltage and x-axis as your time period. Count the number of divisions, multiply it with the volt per division or time per division as the case may be, and find out the amplitude of the signal or voltage of the signal as well as the frequency of the signal. Now we will discuss about the various major knobs that we are concerned in this CRO. These are the basic knobs of adjustment of the CRO. This is the intensity knob. I can decrease the intensity or increase the intensity. This is the intensity knob. Then this is a focus. If I decrease the focus, the lines will become thicker. If I increase the focus, the lines will become thinner. It will get focused more. Okay. Then this is trace rotate. That is, if I ground it, the line is straight here. So if at all there is a slight tilt or slope for this horizontal axis, then you can use a screwdriver and turn this trace rotate to make it horizontal. Now it is already in a horizontal position and usually it will be, or that need not be adjusted every now and then. If you want to adjust, use a screwdriver in this point and make it horizontal. That is trace rotate. So the focus, intensity. So these are the basic adjustments. Now this is the power switch on and off. Off, on. This is in fact a signal that is provided in the CRO to check the CRO. Now I showed you how an AC is measured using a different power supply. I used a AC signal generator. A sine wave was measured here. Even without a signal generator, we can check if the CRO is working fine or showing you the correct reading with the help of a reference signal that is provided by the CRO itself. So this is a reference signal point. Here it is written 0.5 peak to peak, 0.5 volt peak to peak. So it's a square wave of 1 kilohertz and 0.5 volt peak to peak. So if we want to check that, what we should do is take this BNC connector for the first channel and connect it over there. So I'll disconnect it from the other source. This is my BNC connector. The positive knob, I will connect it here in this knob. The negative I need not connect because the measuring system and the source system are the same. So the negative points need not be connected. It's not compulsory. So the positive point I have connected to here. And now I am measuring an AC. So I will release this ground and put it in AC. Now I have connected this calibration signal from the CRO to calibrate the CRO itself. So let's measure the voltage. In fact, you can see this is a square wave, not a sine wave. It's a square wave. If I ground it, the reference zero line is this. So if I release it, you can see it's 1 division height. So 1 division into multiplier here is 0.5 volts per division. So 1 into 0.5, 1 into 0.5, that is 0.5 volt per division. So it is said 0.5 volt per volt is peak to peak. So the measurement is correct. It is written over here 0.5 volt peak to peak. That is what we measured also. Now we have to measure the time period of frequency. So let's measure the time axis. If I shift it slightly with this knob, my one wave is this much. So it is 1 division, 2 division, 1 square wave. So 2 divisions. For subdivisions, you can use the sublines that are given over in the CRO. If it is 1.2, you can measure it like that. 1.4, you can measure it using the subdivisions on the y-axis and x-axis. So now it is 2 divisions, and the multiplier here in this time per division section is 0.5. So 2 into 0.5 is 1. So time period of this wave is 1 millisecond. It is written millisecond here. Hope it's clear for you. It's millisecond here. So 1 millisecond. 1 millisecond. So what will be the frequency then? Time period 1 millisecond means frequency 1 by 1 millisecond, that is 1 kilohertz. So what is written over here is correct, or the CRO is measuring as expected the voltage and the frequency. So the calibration is fine. The signal is used for calibrating the CRO. Hope it is clear. So we discussed the basic knobs of the CRO: intensity, focus, trace rotate, power on and off, and the calibration signal. Depending upon the CRO, that is model of the CRO, this voltage may vary, the reference calibration voltage, but it will be written over here what is its exact value. Now coming to the other knobs, this is the position knob. That is, if you want to change the reference axis, move it up and down, then use this. Similarly, this is the position knob for the second channel. So this is channel 1 and this is channel 2. This is channel 1. I have pressed this knob, so it refers to channel 1. If I press this channel 2 and release the channel 1, now I am using channel 2. So this is the position adjust, vertical position adjust for channel 2. For channel 1, now I am pressed both 1 and 2. So I have pressed both channel 1 and 2. So you can see 2 channels. Vertical adjust for first channel, vertical adjust for second channel. Okay. Now comes the horizontal adjust. It is common for both the channels. I can move this trace horizontally with this horizontal adjust. It's a common knob for both the channels. Now coming to the other important knobs, this is interfine multiplier. Whatever is measured, whatever voltage is measured in this channel, if you want it to be appearing as into phi, you can press this or release it. Similarly, this is for the second channel, but usually we see to it that it is just in the released position, that is, they are not used as multiplication mode. So channel 1, channel 2. Now it is both the channels pressed. You can release channel 2. So now only channel 1 is pressed. Now this is channel 1, channel 2 invert that you need not confuse yourself for the present. Now, this volt per division is over for channel 1. Volt per division for channel 2 over. It's very clear now. Voltage in volt. Here it is millivolt. Here it is, okay, millivolt and volt. That's all. Now, one more adjuster is here. This is called calibration knob. See to it that it is written cal over here. If you can see, an arrow and cal. That means cal knob, you have to keep it in the rightmost position as per the symbol. So this is in the calibration mode. See to it that all the calibrations are in the calibrated off mode. That is this knob I am speaking of. See to it that it is to the rightmost as per this signal that was running off. Level adjust as well as the hold off. These two knobs, hold off and level can be used to make the AC signal that is moving to a stationary point. I'm not sweep mode interpretations. I don't want to confuse you with all the knobs on the CRO. First, as a first level, be familiar with the required knobs, essential knobs. So now I've put it in the auto mode. Sweep mode is auto, so you don't have to much bother about it. Then coming to hold, we discussed minimum and maximum. Using this you can hold the AC signal that is moving into a stationary position. Then this is times per division into 10 magnification. That is what you will be seeing will be into 10 magnification if you press this. If you release this, no multiplication factor will be provided. Usually see to it that this is in the released position. Unless and until it is there is no choice, then press on this button. Usually you will not need it for your usual lab range of frequencies. Now coming to these things, I think you don't have to bother much. This is triggering of the channels, channel 1 triggering, channel 2 triggering. For the present, you can just forget about these knobs, not required. Of course, this knob I have already discussed, ground. If it is pressed, it is AC. If it is released, it is DC. So first release the ground, then do it for AC like this, do this for DC measurement. See to it that when you switch off the CRO or when you are doing your connections, your CRO should be in the ground position so that no signal will enter your CRO without your intention. So the CRO will be safe. So all these things I'm just leaving out. Don't much bother about this. This triggering of channel 1 or 2, you may require it in op-amp circuit when you are doing inverting, non-inverting. You may require this. When two channels are being used for phase identification, you may have to trigger one of these channels that we will discuss when you are discussing the op-amp circuit. Inverting, non-inverting mode. So I think we have covered the basic required knobs of the CRO. Once again, a revision: intensity knob, focus knob, trace, which you can rotate using a screwdriver over here, power, calibration point, first channel, ground, AC/DC point, volt per division for this first channel. Here it is volt, here it is millivolt. This right position is a calibration. See to it that it is always in the calibration position. This is channel 1. If you are doing only channel 1, select channel 1. If you are using both the channels at the same time, select both the channels, then you will get 2 tracers over here. Then this is a vertical position adjust. Vertical position adjust. First channel, this is a vertical position adjust for the second channel. This is a horizontal adjust for both the channels together. You can use the level adjust and the hold off for holding an AC signal in a constant mode. Then these I have left out. Thus you can put it in your auto mode. Then this is a times per division. Here it is millisecond range, here it is second range, and here it is microsecond range. This is a reference point or knob of the knob. It should also be in the calibrated position. This into 10 magnification, don't use it unless it is necessary. Release position is fine so that there is no multiplication at present. Then the rest triggering part I have avoided. This is a channel 2 knob. You can give a BNC connector to that channel also if you want to use 2 channels at the same time. That is all. So vertical adjust section. This is a vertical adjust section. This is a horizontal adjust section. Volt per division section, time per division section. So hope it is clear. And one thing I would like to suggest is, there will be a question, where should we put this volt per division when you are measuring an unknown signal? Always see to it that you put it in a safe position, that is high volt per division, when you are measuring an unknown signal. Once the signal is connected, reduce this multiplier into lower levels and find out which is the level of your voltage. What I mean is, if your signal is say 20 volt and you have put this in a sensitive mode, that is millivolt section, your knob is in the millivolt section. So there is chance that your CRO will get damaged because you are trying to measure your 20 volt signal by using the knob, putting the knob in the millivolt section. That will create problem for you. So better keep it in a high volt per division section, then reduce it if it is an unknown voltage and find out which is the right position for the knob. This is an important point for the safety of your CRO. As far as time per division is concerned, there is no question of safety, but just try out and find out where your unknown frequency would come like, or your time period would come to. So that is all about the CRO in general.